So in this video I'm going to talk a little bit about arithmetic progressions. So let's define Sn is just the sum 1 plus 2 plus 3 up to n. And then the main claim is that Sn is a half n times n plus 1, which is the same, if you like, as a binomial coefficient n plus 1 choose 2. And there's a bunch of different ways to prove this. So one way is like this, so we just write down the definition again. And then let's write it down again, but we'll just write the sum in the opposite order. Okay, so let's just add these two equations together. So then we get 2Sn, and then here you've got the 1 plus n. Let's write that as n plus 1. And here you've got a 2 and an n minus 1, that's n plus 1 again. And so on and so on, and then coming towards the end, the last term, you've got the n there and the n plus 1 and the 1 there, so you get n plus 1 again. So every term here is just equal to n plus 1. And how many terms have we got? Well, you've just here we've taken these two and these two and these two. The first sum has n terms, the second sum has n terms. We're combining them in pairs. So what we've got here again is n terms. Okay, so that's n terms, each of them equal to n plus 1, so that's n times n plus 1. And so that was 2Sn, and so we see that Sn is just half that. Okay, that's what we were supposed to prove. And if we want, we could do a kind of more visual version of this. Okay, let's take n equals 4, say. Okay, so here's our S4. We've got a 1 and a 2 and 3 and 4. So our S4 is just the total number of dots that we've got there. And then we can do the same thing again. Okay, so here 1 and 2 and 3. And there's 4. Okay, so now what we see is that when we draw it this way, we've got we've got 5 rows, which is n plus 1, and 4 columns. That's essentially this is n columns, and so the yeah, and remember so the red dots above this dotted line here, the dots above the line, that's Sn, the dots below the line, that's Sn, you see, because this is 1 plus 2 plus 3 plus 4 below the line, 1 plus 2 plus 3 plus 4 above the line. So altogether we've got 2Sn, that's the total number of dots. There's n times n plus 1 again. So that's just the same as we said on the left. Or yet another way we can say the same thing, essentially. So Sn again is 1 plus 2 plus up to n. So what we've got is n terms equally spaced. Between 1 and n. So the average of all the terms is just going to be in between the two endpoints, because they're all kind of equally spaced between the 1 and the n. So the average is n plus 1 over 2. And so you've got n terms of average n plus 1 over 2. So the total, again, is n plus 1 over 2. The same answer yet again. Okay, Another way we could prove this would be to do it by induction, but we'll leave that as an exercise for the reader.